Let's create a less trivial kernel and assert creation was successful. A shorthand variable for the index of the VectorAddOpenCL kernel within the kernel container array. The actual kernel object assigned to the result of clCreateKernel, which takes a program object, the name of the kernel function within the kernel source, and an output variable error for the error status passed by reference. We check here to make sure that error is CL success. Let's take a look at VectorAddOpenCL. It takes two input vectors, A1 and B2, adds them together, and returns C3. Note that A1 and B2 are const, meaning they are read-only. A diagram, the indices of the different arrays, A1, B2, and C3 arrays. 1 plus 8 is 9. 2 plus 6 is 8, etc. This is what's known as vector addition. You can see it here in the source code. C3 equals A1 plus B2, all of the same index. Note, getGlobalID 0 gets the x-axis because this is a one-dimensional operation. If this were a two-dimensional operation, we would have a call to getGlobalID 0 as well as getGlobalID 1 for the x and y axes respectively. If we were to do a three-dimensional calculation, we would have three calls to getGlobalID. We would have getGlobalID 0, 1, and 2 for the x, y, and z axes respectively. The VectorAddKernel will be stored at index 1 of the kernel container array. The definition of our kernel container, the actual kernel, the work dimensions, the global work offset, global work size, and local work size. It's important to note that if the dimensions, the work dimensions, are one-dimensional, then index 1 and 2 of these arrays here will be ignored. Let's take a look and see if everything compiles correctly. We can see worked and clCreateKernel : VA, clCreateKernel : VA. Everything looks good. Thank you for your time.